This lesson has been developed in the framework of SCILED project. Module 1, Footwear Performance and Comfort. Unit 2, Mechanical Comfort and Footwear Performance.
Lecture 2.6. Slip Resistance.
This lesson is structured as follows. Definitions. Concepts and theory. Role of footwear, structure, materials and components, in slip resistance. Comfort requirements addressing slip resistance, recommended values for parameters. Innovative solutions to support slip resistance.
Definitions, concepts and theory.
Slip resistance is the relative force that resists the tendency of the shoe or foot to slide along the walkway surface. Slip resistance is related to a combination of factors including the walkway surface, the footwear bottom, and the presence of foreign materials between them. Slip resistant is the provision of adequate slip resistance to reduce the likelihood of slip for pedestrians using reasonable care on the walking surface under expected use conditions. The definitions of the terms slip resistance and slip resistant are from ASTM F1646. Friction can be defined as a force that opposes motion. Refer to Figure 2. The weight, W, of the block is equal to the vertical force, N, acting upwards. This represents Newton's third law of motion, which states that for every action there is an equal and opposite reaction. If a force, F, is applied to the block, motion of the block is resisted by the friction force, FF. The friction force, FF, is proportional to the vertical force, N, where FF equals micronewton. The coefficient of friction, COF, is commonly referred to as available friction. Often, the term available friction is used interchangeably with slip resistance. For example, assessing the slip resistance of a shoe sole means determining the amount of available friction it provides or its COF. A larger COF represents a larger friction force and a greater resistance to motion. Conversely, a lower COF represents a smaller friction force and a lower resistance to motion. Mechanical instruments are used to measure the friction forces acting at an interface between a floor surface and shoe material. These apparatus give the coefficient of friction, COF, between a test foot fitted with footwear and a floor in order to assess the pupil's risk of slipping while walking. The classic laws of friction state that COF is independent of contact area and velocity, however these laws are not obeyed by viscoelastic materials like the synthetic polymers used in most shoe outsoles. In the presence of these polymers, the parameters of peak force, loading rate, pressure, and time of contact between the instrument test foot or shoe and test surface influence the COF values, and these parameters may diverge widely using different instrument types. To be compared, the COF value need to be associated with a specific calibrated instrument type, test foot material, and test method. The standard ISO 13287 describes a method to evaluate the slip resistance of personal protective equipment, PPE, footwear. In this test method, the footwear is placed on a surface, subjected to a given normal force, and moved horizontally relative to the surface, or the surface is moved horizontally relative to the footwear. The frictional force and the normal force are measured and the dynamic coefficient of friction, COF, is calculated. The footwear shall be tested in one or more of the following modes. 1. Forward heel slip at angled contact. 2. Backward slip on the forepart. 3. Forward flat slip. The heel test mode is considered to be the most important in relation to reducing the risk of pedestrian slip. The footwear can be tested in different floors and conditions, for example, ceramic tile floor or steel floor with a specific soap solution or glycerin. This test can also be performed on an ice floor or other that we would like to test for a specific application. Another method available to test the slip resistance is the ramp test, described in the standards DIN 51130, DIN 51097 and BS 4592. In this method, floors and footwear can be tested. This type of test classifies the footwear as being high, moderate or low slip potential on a given surface with a given contaminant.
Role of footwear in slip resistance.
The function of footwear is to provide protection, safety, comfort, and enhanced performance during dynamic and static activities. With respect to safety and performance, it is essential that footwear prevents slipping. The slip resistance is related with the contact of the footwear with the floor and is influenced by several parameters that include
the type of floor. For example, the footwear can have a different behavior on a ceramic, stone, plastic or inox floor. The condition of floor. Is common sense that the slip resistance of footwear is lower in a wet floor than in a dry floor in the shoe. In this case it's necessary to select the most suitable bottom components, especially in terms of sole. Shoes with good fitting can maximize to synchronize the walking gait, thus reduce slip risk caused by human factor.
Slip resistance is highly dependent on the sole in terms of material composition, tread pattern and bottom shape. A higher contact area between the shoe/floor will increase the coefficient of friction and reduce the slip probability. Also, bottom cleats that promote liquids flow, preventing liquids trapping between the sole and floor, will reduce the slip probability. In general, a softer sole and close-packed tread pattern work well with fluid contaminants and indoor environments. A more open pattern works better outdoors or with solid contaminants. The only sure way to tell is to test the footwear using testing systems and in the use environment. In this case, tread patterns should not become clogged with any waste or debris on the floor. If soles do clog up, redesign the sole, for example with a wider space between the cleats and a deeper tread pattern. Note that slip resistance properties can change with wear. For example, some soles can deteriorate with wear, especially when the cleats become worn down. Therefore, it is essential to promote sole adequate abrasion resistance.
Slip is influenced by sole materials composition and design.
Different outsole materials are available, namely, nature rubber, NR, nitrile rubber, NBR, ethylene vinyl acetate copolymer, EVA, polyurethane, PU, polyvinyl chloride, PVC, thermoplastic rubber, TPR, or others. Generally, the NR outsole has the best slip resistance on the dry surface, whereas the NBR and PU have the best integral slip resistance performance on the contaminated floor surface such as wet, oily and etc. EVA, PVC and TPR outsole are considered to have the highest risk occurring slippery. In terms of wet icy condition, which is most slippery floor condition, DPR outsole is the best choice to keep you away from slip and falls. Cleats. The pattern shape is very important. These shapes are responsible for gripping the floor when the shoe contact with contaminant surface. The slip resistance pattern design is trend to use simple geometric, regular and repeatable shapes such as circle, rectangular, square, which can offer maximum grip and efficient contaminant dispersion. Certain shape might be better than others. For example, the circle shape is recommended because the flat edge of outsoles with hexagons, triangles, or square shapes can sometimes create a wall that prevents liquid from moving away from the shoe sole. In terms of the shape size, the smaller scale is better within 3 to 20 mm. Outsole hardness. The softer outsole is, the better slip resistance performance could be expected. The leading edge of cleat of outsole pattern shall not be rounded but as flat as possible. Drainage channel. The recommended guideline is the width of channel of outsole pattern shall be at least 2 mm in depth within range from 2 to 7 mm. The important function of the channel is to store the contaminant which is squeezed from the contact area, then drain the contaminant away from the sole bottom. If the channel too small and thin, the space may not be wide enough to channel liquid to the outer edges of the outsole, potentially increasing the chance of a slip or fall. Similar to the tile design, the channel with streamlined design should help the contaminant drainage and improve the slip resistance. In order to create even better traction, some design chooses further small channels that divide each cleat into 3 or 4 movable parts, hence to further increasing the grip effect.
Comfort requirements addressing slip resistance.
Comfort and fit. Besides the general guideline described above, we also need to consider about the comfort and fit. The most important feature is that shoes should be fully fit feet. Shoes with good fitting can maximize to synchronize your walking gait, thus reduce slip risk caused by human factor.
The main characteristics and requirements related to use and comfort for soles are: slip resistance, flexibility and stability, water resistance, shock absorption and cushioning, plantar pressure distribution, thermal insulation.
As example, in this table are presented the recommended values of the coefficient of friction for PPE footwear, tested in different conditions following standard ISO 13287. For more information, please consult standards ISO 20345, ISO 20346 and ISO 20347, in the case of PPE professional footwear, and the technical report ISO/DR 20880, for components to be used in casual and school footwear. men's and women's footwear, footwear for cold conditions, among others. Just some remarks on this subject. If a footwear is claiming slip resistance, it is automatically in the field of the PPE regulation, before the PPE directive, and it is a PPE and it shall be CE marked. It will be possible for a footwear manufacturer or a brand to check that the shoes, soles used in his production are not dangerous for slipping. But it will be internally and not communicated in the footwear labeling as a claimed property. However, it will be possible to claim a high adherence sole for special uses, for example casual or sport footwear, footwear for climbing, among others. In this case it is not a safety property and therefore not a PPE. ISO TR 20880 is a technical report giving level of performance is being revised.
In this table you can find coefficient of friction values for 3 slip resistance level described in standard BS 4592.
Innovative solutions to support slip resistance.
The safety shoe piston from To Work For features a full grip Michelin sole. The characteristics of this sole are, biting edges that improves performance on icy and snowy surfaces, aggressive sculptures on shoulders providing lateral traction and emphasize the sporty athletic look, tread design that assures self-cleaning from sand and dust, micro pumps to absorb and evacuate water maintaining wide contact with the ground, multi-directional anti-slip tread that provides excellent adherence on all types of slippery floor surface. Water tips break water surface reducing the risk of slipping and improving adherence. These characteristics lead to a multi-directional traction and adherence on any surface with increased lateral control, adaptability to different grounds, excellent performance on outdoor surfaces and multifunctional outdoor work sole designed to perform and allow complete control to the user.